Hi everyone, this is Dr. Anilkumar, working as an assistant professor, Department of ECE, Lindy Institute of Engineering and Technology, Vijayanagaram. Today, in this session, we are going to discuss, we are going to learn about the modeling of any structure in Ansys HFSS Electromagnetic Simulation Tool. So, we are working under Applied Electromagnetics Research Group in the Department of ECE at Lindy Institute of Engineering and Technology, Vijayanagaram. So electromagnetics is one of the important and emerging domain in the electronics and communication engineering. So every student should focus on this particular domain. There are not many applications after manufacturing the PCBs, printed circuit boards, the electromagnetic induction and electromagnetic compatibility tests should be done so as to check the interference of the electromagnetics with respect to other uh, devices which are surrounding to the uh, designed device or manufactured device. Or sometimes, many times, we have many devices, many electronic components and many electronic equipments, sophisticated equipments will be installed in the present day communication modules like smartphones, vehicles, automotives, and other biomagnetic, electromagnetic based instrumentation systems. So in such cases, every system should be verified and tested with respect to its electromagnetic compatibility and electromagnetic interference. So in such scenario, the electromagnetic waves, which have the wide range of spectrum, and there are many devices which may propagate the electromagnetic waves which are used to generate the electromagnetic waves like antennas and which are used to transmit the electromagnetic waves and which are used to receive the electromagnetic waves. And many devices in RF, microwave and communication will need this spectrum. So such kind of device modeling like antennas, filters, couplers, directional couplers, attenuators, resonators, reflectors, these type of many more devices, many more modules can be designed and analyzed through the electromagnetic simulation tools. So one of the popular electromagnetic simulation tool is Ansys HFSS. The HFSS is termed as the abbreviated form of HFSS is High Frequency Structure Simulator. The name itself consisting of high frequency structures simulator. So it can do the simulations and it can solve the problems of the high frequency structures. Usually the high frequency structures are nothing but the devices we are using like smartphones, wristwatches, smartwatches, other medical equipment, so satellite communication based equipment, digital TV technology, D2H, direct to home television systems, and other wireless communication, smart wireless communication systems and compact wireless communication systems modules we are using, those are all comes under high frequency devices. So coming to this modeling in the ANSYS HFSS simulation tool, we are going to focus in this session. Let us go to the ANSYS HFSS simulation tool first. So I am navigating to the ANSYS HFSS simulation tool through ANSYS Electronics Desktop. So this is the complete package which enables many components like HFSS, Q3D extractor, circuit analysis, and the Maxwell's ANSYS Maxwell's moreover simpler. And nowadays the recent versions of the Ansys Electronics desktop is equipped with many more tools which is collaboratively working with multi-physics, optics, and other domains. So complete graphical visualization tools are available in the Ansys simulation tools, electromagnetic simulation tools. Even thermal analysis also coming in this simulation tool. So I am just open this Ansys electronics desktop. So after opening, I am unable to see any workspace here. So I would like to mention few things. First one is this one, the menu bar is there, file, edit, view, project, tools, windows, help. In the file menu, we can create new files. We can open the files. We can open the examples which are inbuilt located. We can close the files. We can save and archive. Even we can export and import options are also available. And the recent files will be shown there. And in edit option, undo, redo, cut, these options we are very much familiar. And view option is there for enabling particular menu bars and particular tools in this environment. Next, in the project menu, we have what are all the components discussed in this tool. HFSS 3D layout, and IE Q3D 2D extractor, Maxwell's 3D design, Maxwell 2D design, RM expert design, Maxwell secure design, simpler design, filter design, and documentation file. Moreover, two more tools are available with this Ansys electronics desktop, that is Savant and EMIT. And tools, coming to the tools, some specific options we can set before or during the running of this electromagnetic simulation tool. And the windows, what are windows available, and help. If you have any doubt, if you have any concept related information regarding this simulation tool, you can directly go to help and take the necessary information and we can proceed further. So I am going to launch the HFSS tool. So by directly going to project menu and insert HFSS design, I can launch the HFSS. Otherwise, here HFSS is there. There many options are there. HFSS 3D layout, HFSS IE, launch 7, launch EMIT. So I'm going to launch the HFSS by clicking on this icon. This icon is nothing but the magic T icon. It is similarly looking like the magic T, which is one of the microwave component. So I'm clicking on this HFSS. This one is known as project manager, and this one is known as properties window, and the below two windows are known as message manager and progress window. So it is taking some time to load based on your desktop or laptop configuration. So better it is necessary to have a good configuration system for launching and doing the projects in Ansys Electronics desktop. So now I'm able to see the working space, the white working space, which is having few things. Sorry. Here, x-axis is there, which is in red color, and y-axis is there, which is a green color axis, line, arrow mark, and z-axis is there, which is blue in color. And there is a grid exist in this white working space. This space is known as workspace, and this grid represents the plane which we are doing the modeling. So this plane, what is this plane? How you can identify this plane? And this below this one thing is there, that is called ruler. Okay, ruler. You can enable or disable this ruler by clicking on this, you can enable or disable. So it will show the scale of the model you are designing. So whenever you are going to zoom by scrolling your mouse, it will scale. It will show the scaling of this particular area, working area. So you can just click on this to hide this ruler, and this is the grid. If you want to don't want to show this grid, you can click on this. Like this, you can enable or disable. So here 3D option is there, in plane view is there, out of plane, along x-axis movement, along y-axis and along z-axis movements are there. So basically the option is set to 3D. Next, to change the plane, you have to go to this option XY. So this is the plane option is there. Here there you can find the drop down menu XY, YZ and ZX. So you are able to see the plane changing of the plane. Okay, by default we are keeping this plane as setting this plane as XY plane. Now I'm going to introduce you the zoom option. In the zoom options, zoom in, zoom out options are there, and the pan option is there for just moving the entire structure without disturbing others. Pan option is there, and the rotate option is there. Rotate model center, rotate with respect to, and the rotate current axis, rotate the screen center, and spin. So these options are there. So rotate by default rotate option. With the rotate option, you can rotate the three-dimensional coordinate axis and three-dimensional coordinate system which is existing in this workspace as you desire. And orientation is there. You can orient the structures as top view, bottom view, and right view, left view, front view, back view, trimetric, dimetric, and isometric. So these are the different orientations of the structure. To see your structure, to see the designed structure, different manners you have these type of things are available. So save option is there, copy paste, cut copy paste, undo, redo, delete. Directly these options are available. And here an option is there, an icon is there, show all objects in the active view. Show all objects in the active view. And this one, hide or show overlaid visualization in the active view. So when there are a lot more number of structures which are stacked over one over the other, you can hide or show the structures. And whenever the green tick mark is there, that means the structure should be showed. And into mark, cross mark is there, red cross mark is there, then it is known as hide selected objects in the active view. And fit screen option is there. Then we are going to see the other tools like geometries. So these options, geometry options are there. Here they are categorized like this. This one is point. Point is the basic of this geometry. So with the points only, many structures like lines, surfaces, 3D objects, all will be formed only with the point. So number of points, locus of points will get something, that is a curve, closed curve, open curve, and the surfaces, and this one, three-dimensional structures, planes, like this. So point is there, straight line is there, spline is there, arc, 3-point arc is there, and the center point arc is there. Sometimes we have to model the curves based on a specific equation. So equation based curve option is also there. These are lines. And next we have planar surfaces or simply surfaces. The basic primitive shapes are rectangle, circle, polygon, regular polygon, ellipse, and equation based surface. Then there exist three-dimensional primitive shapes: box, cylinder, This one is regular polyhedron. That means all the sides are equal. Conical object, sphere, torus, bondwags. Bondwags are mostly used to design the PCB circuits in which the micro level components exist, like processors, inbuilt processors. Bondwags will be tied to or connected to the tracks or lead pins. And this one is a spiral, and this one is helix. Under special configurations, these structures will be enabled. Next, these are about the surface, surfaces, lines, and the three-dimensional structures. After creating the surfaces, sometimes we need its different types of operations like moving that structure, rotating that structure, mirroring that structure, and mirror duplicating the structure, rotating but duplicate and rotate like that, and move along a specific line. Those options are also available here. And sometimes we need to add two structures. That means we need to add two lines, two or more curves, two or more surfaces, two or more three-dimensional geometries, but not we can't add a 3D structure and a 2D structure. We can't add a 2D structure and 1D structure. We can't add 3D structure and 1D structure and vice versa. So similar group of structures, we can unite them, we can subtract them, we can intersect them, and we can split them. So unite, subtract, intersect, these operations are called Boolean operations, which are used in this Ansys Electromagnetics HFSS simulation tool. Sometimes we need to split the structure. We don't need complete structure. Then we have the option of split. And imprint structure. Imprint structure means some structure we have, and the other structures like we have some sticker, we have purchased some sticker, and we placed it on a particular conformal or different surface. Then we have to uh, make the imprint of the structure. Then we will use this operation. Sometimes the corners of the structure will be there. Those corners should not become a corner. So rather than that, corner should be in a rounded manner or chamfer manner. That means truncated manner. Then this fillet and chamfer options we will use. Next, surface, surface movement, detachment, create object from surfaces. So like this, some options will be there with respect to surface. And the sheets, with respect to sheet, we can thick the sheet, we can wrap the sheet, and we can project the sheet. So these options are there. And edges we can detach from the main structure, and we can create an object from the edges also, and we can move the edges. So this is the original coordinate system, which is this is the original coordinate system, XYZ coordinate system. The origin is lying here, and we can create the relative coordinate system also. That is one thing. Next, measure. To measure the different point locations and the lengths, heights, other points, we have the measure option. So in the measure option, we can measure the position, we can measure the edge length or edge distances, edge dimensions. Simply we can call edge dimensions, and the face dimensions, face centers, angles, the object dimensions. So these can be obtained through this measure option. So these are things whenever we do the work, then we can get the things. So first of all, uh, to learn the modeling, we have to familiarize with the coordinate system. So this one is the x-axis, this one is the x-axis, and this one is the green color axis is nothing but y-axis. Just a minute. The red color one is the x-axis, and the green color one is the y-axis, and z z-axis is represented in this color, blue color. Now this is the x, y, z. That means x-axis is looking positive direction here, and the negative direction is in this direction. And y-axis is positive direction along this green line, and opposite direction to the y-axis there is negative y-axis representation. And z-axis is looking upward as per my orientation, my coordinate system orientation, and the negative z-axis, negative z direction we have to take in the bottom direction. So this one we have to keep in mind. So I am just making this coordinate system by double clicking and selecting the orientation as a top view. So in the top view, the basic HFSS structure, HFSS workspace will look like, will appears like this. Regularly, when we studied this graphs in our schooling system, in our academics, the graphs will be usually like this. So this one will be the x-axis. This one will be the x-axis, and this one will be the y-axis, like this. That means this is positive x, this is positive y, and negative x, negative y will be in this direction. But we have to keep in mind when it comes to HFSS, this entire coordinate system will gets rotated. This entire coordinate system will gets rotated. So that's we have to keep in mind. So rotate right 90 degrees, then we'll get the coordinate system which is similar to the display in the HFSS. So then x-axis like this, y-axis like this. So that means we have the four quadrants. Let us take this plane only. This we are working in this plane only. So they have four quadrants. One is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Quadrant 1 will be plus plus. Quadrant 2 will be plus minus minus plus. Let's see here. I'm changing everything. Now the things are getting changing. So you just identify the changes, then you can simply understand. This is x-axis, that means positive x, and this one is y-axis. This one is negative y. This one is negative x. Then this is Q1, quadrant 1, positive, positive. I am taking only one plane. The plane is nothing but xy plane. Only xy plane I am taking. And this case Q2, that is negative, positive for the values. And this will be the Q3. This one will be negative and negative. Q4, that is positive and negative. That means the first one is nothing but x value, and second one is nothing but y value. So x value is positive in first quadrant, which lies here. XY values are negative and positive in the quadrant 2. Both XY values are negatives in quadrant 3, and the plus minus signs will be appeared in the quadrant 4. So coming to this particular thing in the HFSS2. So first you draw a point, locate a point here and another point here. Just locate a point here. Whenever you start drawing anything, so you have to click on this any of the primitive shapes. Immediately the measure data window will appear. In the measure data window, the first one is position 1, in brackets it is written as reference. That is, reference is nothing but origin 000 millimeters. Position 2 is current. Current means wherever you are moving in the workspace, that coordinate points it will show. So now it is showing minus 0.9, minus 0.8, comma 0. And here I am moved minus 0.9, 0.80. Now I moved again minus 0.6, 0.80. Now 0.8, 0.60. Now 0.8, minus 0.50. Now minus 1.3, minus 3.10. Like that, wherever I will move, the current position will be reflected here in the position 2 current. And distance, the distance is usually calculated here with respect to position 1 and position 2. Position 1 is 000 and position 2 is wherever you are, that is the position. And the distance is nothing but the Euclidean distance. The distance is square root of x minus x1 whole square plus y minus y1 whole square plus z minus z1 whole square, or whatever the formula you have. And x distance, y distance, z distance is, suppose I am locating this point here where the red pointer is appear in the screen. The x distance is 0.6 mm, y distance is 0.7 mm, z distance is 0 mm. So as we are doing the modeling in the xy plane, then there won't be any z coordinate. That means the z coordinate value will becomes 0. Once again, I'm repeating, as we are doing the modeling in the xy plane, there won't be any z value. That is, z is equals to 0. That means z is equal to 0 means the xy plane. Y is equals to 0 means xz plane. X is equal to 0 means the plane is yz. So opposite to other axis, the plane will be constructed. Now I am going to check the x distance, y distance, and z distance. So x distance is nothing but the point where I have located on the workspace from x-axis. From x-axis, what is the perpendicular distance? If you draw a perpendicular line towards the x-axis from the point, that distance is known as x distance. Similarly, if you draw a line from the point towards the y-axis, that is called y distance. So how this distance can be calculated, I will just let you know. So I am taking the point here. Let us take the point P here. This all you know very well, very much familiar in your geometry while you are schooling. But once again, we have to recollect the things. So this one will be the y distance, and this one will be the, this is not perpendicular as actually, this one will be the x distance, and there won't be z distance. So this is the point P and the distance criteria. Uh, actual distance is, the initial point is this one, that is P1, and this is P2. Then this is the distance between those 2 points. So there won't be any use of drawing a point. Now first I will draw a line. So I can draw a line in this particular plane, xy plane, in any of the manner. Like this I can draw. So first I will click on this draw line option. The same options are available in this draw menu: line, spline, arc, in the arc 3-point and center point arc equation based curves. So here one section is divided. So these are all lines. And rectangle, ellipse, circle, regular polygon, equation based surface. These are all categorized into one particular domain, that is surfaces. Box, cylinder, regular polyhedron, cone, sphere, torus, helix, spiral, bond wave. These are categorized into some other menu, that is 3-dimensional structure. And the sweep option is there with respect to point and with respect to line, not with respect to point. With respect to line, we can sweep the structures and we can create the surfaces and 3-dimensional structures. And user defined primitives. So from examples, we can get the things in DLL and Python. RM expert, I'm expert in the many structures are there, double cage, end cap, band. So these structures are also available, wave coil, and segmented helix, polygon helix, rectangular helix, like this. The segmented helix is also there. We also define models. From antenna toolkit, we can import the structures like horn, corrugated horn, log periodic, log tooth and log trap, spiral, Archimedean spiral, log sinus spirals, Vivaldi, step Vivaldi and Vivaldi. So on day spiral inductors, these special options are coming with newer versions. So these are the basic points. Now we have to draw this line. So I am drawing this line. You can just observe the measure data option. First what we have to do is click the point wherever you want. Then navigate at what distance you want the line and whatever position you want the line. So I am going to draw a line like this. Okay. So again I am doing this like this. Okay, now see the position 1, the reference is initially in that case the reference was 0 comma 0 comma 0, that is in origin. Now the position 1, the reference point became minus 0.5 minus 0.8 comma 0. That means the left side point where I have started the draw line option, that point is taken as position 1. And where the red pointer is showing, or the cursor in the HFSS workspace is showing, that is the current point, which is minus 0.8 and 0.8 and z coordinate is 0. So this is the uh, coordinates of the uh, line, straight line. And the angle P2O minus P1O, that means with respect to origin, what is the angle? So with respect to origin, from origin P1, P2. So what is the angle subtending? That angle it will display. So now this is the line. So you have to double click the cursor where you have to end that or terminate the line. Otherwise, the same line, I am doing it again. So this is one line. Again, it will show two arrows. So doing it again. So first click on one point, then you will see two arrow marks, which is along the x-axis and which is parallel to the y-axis. That means you can navigate in both the axis, that is x-axis as well as y-axis. Otherwise, you can move in that plane. That is the point. So now I will click the second point of the line, then again it will show the axis representation, the navigation tools. So if you want to continue like this, again it will show the marks. Here the marks are showing. I'm clicking. Here again the marks are showing, directions are showing. Here again the directions are showing like this. If you terminate this structure will become a open-ended line, open curve or open-ended line. So this is the structure. So I am deleting the structure. Before deleting, I will show you few things in this particular window. Model category is there. In that model category, lines are there. So only we are dealing with lines, that then the lines will be enabled. The polyline 1, the name is polyline 1, automatically it will assign, and polyline 2, this is the polyline 2. So whichever structure we are selecting, the structure will be appeared in pink color. So you can easily identify the structure which we are selecting. So this is the structure and this is the category. Lines, surfaces are 3D structures like this. So polyline 1, polyline 2. In this, if you can open this other options, so create polyline. This is the command which is running behind the modeling. So yes, the software is GUI, graphical user interface. We are only dealing with the options and other things. We doesn't know about this coding, which is runs behind this particular tool. So create polyline is one command to create this polyline. So if you uh, open this option, then again create line is there. So if you click on this, then you will see, you are able to see the uh, perfectly selected the line. Now you observe minor changes, you observe a little changes, what is happening in this particular workspace. So polyline 1 is there. If you click on this model, there are no properties visible here. And click on the lines, no properties window is enabled. And if you click on the polyline, we have several properties. The first one is name, and the name we have to enter. Automatically it has given polyline 1. And orientation, global, that means global coordinate system. If you created another coordinate system which is relative to this, then other option will also be enabled. And model, so if you tick this model, that means whether you are interested that structure to be in the part of your simulation. If you doesn't tick this structure, that means the structure will not be considered for the simulation. So it won't consider the structure during the simulation by the electromagnetic solver. And group model and display, another option is there. I will just expand this window. Display wireframe. So display wireframe will be worked well for the three-dimensional structures and two-dimensional structures, not for the lines. And material appearance, whether it should be appeared or not. And color, we can apply different colors and we can provide transparency, show the direction. So the same options, if you double click on this, the same options will be appeared under properties window. So you can select this like this also. So the color of this structure, color of this line became orange now onwards. Then I will click on this create polyline. Then you just see the command name is create polyline. Coordinate system is global. Number of points is 2. So this line is made of 2 points only. Number of curves is 1. Only one curve is there. That is nothing but line. And cross section. So cross section is there. Type. In the type option we have none. So if you double click on the same thing, the same options will be enabled, but few other options will also be appeared. The command, coordinate system, number of points, number of curves, and regarding the cross section, initially it is allocated to type none. So if you click on this drop down menu, then you will have different options. The type is none, type is line, circle, rectangle, isosceles, trapezoid. So if you click on this line, what is the changes we are going to observe? Just see here. And orientation, automatic, x-axis orientation, y-z orientations. Okay, that means it is the structure is looking towards x-axis, or the structure is oriented towards y-axis, and the structure is oriented towards the z-axis. When you set these particular options, I will let you know everything. Next, width or diameter, top width, height, number of segments, bend type, corner or curved. So let us see one by one the options. Now I am going to select this type into line. Type into line. Now I am selecting the width or diameter as 5 mm. 5 mm. Just apply it. Please happen. The line became another structure, which is having the which became a surface or a sheet. Now what happened earlier, the polyline 1 which was under lines, now it came under sheets. That means whenever that polyline was converted into sheet, it will emerge into sheet. And here one thing, under lines the structure name is directly appeared, but under sheets the structure name is not directly appeared, which is hierarchical under unassigned. What is this unassigned means? We have to keep this point important. Um, you have to remember this point particularly. The thing is, sheets sheets will be applied with boundary conditions. So in the electromagnetic waves and transmission lines, we have seen that boundary conditions like perfect E, perfect H, that means perfect electric boundary, perfect magnetic boundary, radiation boundary, lumped boundaries like lumped RLC boundaries, impedance boundaries. So different boundary conditions are there. So those things we have to apply. And one more point we have to keep in mind is this is for sheets or surfaces, and for 3d structures 3d structures are solids. So for solids we have to assign the material material properties we have to assign. So this point we have to keep in mind. So coming to this, if you won't assign those things to the sheets or solids, then it will be under unassigned. Now another magic we will see. So create polyline again. So now keep the width as 2 and click on apply. Then the dimension was reduced. So what is 2 here? You just check what is 2 here. Now to identify what is that width, we don't know the width, in which dimension it is going on, we don't know. But the line was initially was like this the line was there. So the line is, we are assigning the width means this length and this length, the width was applied. So now click right click on the workspace, go to the measure option, position. Now click on this point, just click on this and just keep the cursor here, don't click on this. Then you can find the distance is 1.627, 1.627, and you are already clicked on this point and you just keep the mouse cursor here, then the distance is 2 mm. So whatever width we are assigned there, the distance is in this direction. So not in this direction. This one is nothing but the line length. Initially, water length we have given to the line by forming 2 points. That is the length, and this is the width, right? So now another magic we will do. Double click on this to top width. Top width. Let us take 3 mm. Now apply. Top width is 3 mm. Height you can take 2 mm. Let's take some random values. 2 mm. Click on OK. Now see how the structure is going to be. So there is no change in the structure. There is no change in the structure. Why? Because the line will be converted into sheet only by the width or diameter. Okay. So now these options to get the impact of these top width, height, number of segments. Let us switch over to the rectangle. This is the thing. So top width is 3 mm and the height is 2 mm. So let us check whether these are correct or not. So now I am going to do the measure, position, height. Height is how much? Distance it is indicated as 2 mm. So you can pause the tracking. Here the distance is 2 mm and that distance is also 2 mm. Let's say both are same. Now this is the length of this line initially. Now it became a box. Now what is that? The distance is 1.627888206, like that. And what is this one? Initially we have assigned 2 mm width. That is the thing. Okay. So these are the things. Now you observe this thing, polygon 1 emerged into solids, and the material assignment by default it was already assigned with vacuum. Now click on this create polygon option. After that, click on this isosceles trapezoid. Now apply. So top width you will work, top width and the other things will be worked for this isosceles trapezoid. So this is the structure. Earlier it was box, beginning it was line, now we converted into sheet, then we converted into box, then we converted into trapezoid structure. So if you can change that structure values 5, so the width will become changes. So this is one type of structure. It's a wedge shape structure. So click on this. So number of segments 5. Is there any significance? No significance. Okay, leave it. So this is the application of different options coming in the line. So now click on the circle. So this is the thing. So number of segments we have kept to 5. So if you kept to 0, if you keep this point as 0, then it will become a cylinder. So what you drawing earlier? The earlier you have drawing a polyline, now it became a cylinder, simple cylinder. So if you assign these values, top width as 5 instead of 5, just keep it as 0. What will happen? Just see. It can work. So no change. Height 0. What will happen? No change. Okay, like that you have to check whether the change is there or not based on that. Why? Because you have created circle only, so it will work like that. So I am taking back this one, and we will check the orientation option. So x-axis apply. I think the structure is some problem was there. Circle instead of that y-axis. So no change. Okay, some garbage value already replaced so that this won't work. Okay. Now I'm going to show you orientation Z. Is there any change? No change. No change. So like that we have to check everything. So I'm deleting this one. Okay, I will make it clear. We will keep this polyline and we will apply in another thing. So say let us take the second polyline. We apply the same things. Suppose you don't want this length, you don't want this line, then what you have to do is you can check one by one which line you don't want. So I am clicking on this create line. This line is enabled, appeared strongly, and this line is appeared boldly, and this one is next this one, next this one, next this one, next this one, next this one. So if you don't want this line, then right click, delete endpoint. Click on the delete endpoint, then you won't get this line. So until done, this will be appeared. Now it will show number of points 7, number of curves 6, type none, orientation this one and this one. So now click on this circle. Width diameter is 0.5 mm. Apply. So the same structure, same polyline. Now it became like a tube, like a solid tube. Okay. So this is one of the application of the hidden points in this particular create polyline option. In the properties window, you can check these points. So if you want a thin line, thin tube, then click on this, do apply, like it is showing it like a wire. Okay, the bended wire. Next orientation, x-axis, no change. Again, click on this. do it automatic. Number of segments, if you keep 5, then it will become a pentagon shaped structure like this. The face will be pentagon type. Otherwise, if you keep the number of segments as 4, then the squared, the squared wire, a squared tube, a squared thing can be obtained. So this will be the structure. So in the different plane of orientations. Again, click on this. Now, number of segments I am keeping as 10. Now we can see what is the number of edges we are having. Now number of segments 100, then it will be almost similar to the circle, almost close similar to the circle. So by default it is 0, keep it as it is. But even you keep it as 0, even you select it as circle, it won't become a accurate circle. But due to the simulation tool environment, it will display like that only. Next, top width. What is the top width value? We just keep the value 1 here. Now check the thing. There is no change. Okay. So after that, click on this line rectangle. Click on this rectangle. So now the same polyline has become a rectangular sheet. It's just looking like a strip of conductor, a strip of surface over here. And next, if you click on this height option under rectangle and apply the same things, no change. Yes, there is a change. And now the structure became like a wall. It became like a wall, or it became like a clip clip kind of structure. So this is the structure. And if you click uh, a rectangle, instead of rectangle, keep the isosceles trapezoid and keep the different values of this top width and height. Now check what the structure is going to be. So as the dimensions are very much large, the structure became an irregular. So let us take other values and try the design. So instead of 3, I am keeping 1.2. Let us see what is the structure. So this will be the structure. I will reduce the structure furthermore. Now see this one. This is the structure. So uh, different widths are having here. So like that. So what we can understand is the same polyline we have drawn earlier. It can be converted into circle. It can be converted into rectangle, isosceles trapezoid, or if you draw other uh, more curves using this polyline option, then the same thing will be in a different manner. You can create your individual and arbitrary structures like this. So this is the purpose of properties window, checking the properties window under a specific command like create polyline. Okay. Now I am deleting the structure. We will work out on this particular line, polyline 1. So actually, for the demonstration purpose, I have drawn a line uh, as per my wish points. So now I want to change these points. I want to change these points. That means this is x-axis. From x-axis, the line should be parallel to y-axis. My constraints are the line should be parallel to y-axis and it should be aligned symmetrical with respect to x-axis. Symmetrical with respect to x-axis means the line, the x-axis will divide the line in two equal parts, two equal parts, so that the thing should be modified. So now what we have to do is click on the create line option. Now check the point 1 and point 2 coordinates. Let us take the line length. Length of the line is 10 mm. let us take the length of the line is 10 mm. So my constraint is the line should be parallel to the y-axis, perpendicular to the x-axis. That means the y-axis length, that means the y size will be 10 mm. So as the x-axis is dividing the line into equal parts, the 10 mm becomes 5 mm. That means minus 5 coordinate in the upper point, that is point 1, and the bottom point, that is point 2, the plus 5 of the y coordinate will be taking place. So now click on apply, just click on OK. Now check the structure how it became. The length was extended as you wish, but the line is not parallel to the y-axis. So what we have to do? We have to check whether the x distances, no, the y distances are same or not. So if you check the y distances, we have to check the x coordinate. So x coordinate is minus 0.5 for 1 and minus 0.8 for zero point 0.2. So let us take the line should be 5 mm upper from the y-axis. That means the 5 minus 5 minus 5, and here also minus 5, here also minus 5. Just apply. Now the structure, to visualize the structure, just zoom out it. Now check whether the structure is perfectly aligned as per your wish. Go to the measure option, position. So click here, fix the point, click the point, and just place the cursor here. Now the distance, you can check it as 10 mm. X distance is 0 mm, Y distance is 10 mm, Z distance is 0 mm. So actual distance is 10 mm. This is as per your wish. Now check whether whether this line was segmented by this x-axis in two equal parts. So now click here and place the cursor exactly at the midpoint of the line. Now the value is 5 and total is 10. So half is segmented. Perfect. Next, whether whether this straight line is parallel to the y-axis and it is at the distance of 5 mm. Now click the point at the origin, click the cursor at the origin. Now place this, how much it is showing, distance is 5. If you click here, if you move the cursor here, if you place the cursor here also, the x distance is 5. If you place the cursor here also, the x distance is 5. Just check it. The x distance is 5. I am pausing this one, and x distance is 5. So that is the distance we have already taken. So this is the checking of this particular structure, whether it is correctly formed, correctly aligned or not as per our wishes. So I'm closing this one. So like this, suppose this line should be placed 5 mm above the xy plane, 5 mm above the xy plane. Then click on this one, and point 1 we have to place z coordinate as 5. Point 2 we have to place z coordinate as 5. Now the structure, the line was located 5 mm from the xy plane. It's simply looking perfect. If you wish to check, then go to the measure option. Go to the measure option, click here and click, just place the cursor at the origin. Now check the Z distance. Z distance is 5. Already it is indicated as 5. So then it is perfect, perfectly aligned. Next, after completion of this line, after completion of the demo of this line, we have other tools like spline. So spline is a different curve like this. Like this, we can form different types of curves in this particular plane only. If you don't do in this plane, then the curve will be in different planes. So this is an arbitrary structure, and I am going to close it here. With the spline only, I have created the surface. So this is one type of operation. So this is not applied with any boundary condition. That's why it is shown under sheets with unassigned. So now I am deleting this one. We will check it another. And 3-point arc. Just see. In the geometry, in your schooling days, you might have seen this. So 3-point arc. What is 3-point arc? Just whatever structure you want to do, you want to draw in the HFSS workspace. First, click on the structure. Click the cursor in the workspace. Then you start doing this. This is the arc. So from this point, the arc will be formed. This point, the arc will be formed like this, like this. So if you can extend this design, it won't stop. But if you don't wish to extend the design, then you have to double click on this. So like that. Okay. Next, center point arc. Center point arc is nothing but it is just like your schooling days. You have used a different tool to draw the arcs in the mathematics. So like this. If you wish to extend this center point arc, then it will be extendable. But many of the cases it should not be extended. So it is as per the designer's wish. Next, equation based services we will see whenever it requires. And the next option is we will go with the 2D structures. We will go with the 2D structures now. So first I am taking the rectangular sheet. How to draw a rectangular sheet. So this is the workspace. Actually the workspace was like this. Now to fit the view, I click the Control D at a time. Control D. Now I have to create a rectangle. So before creating the rectangle, we have to check the position. So in what way you want to appear, you want to make the rectangle to be appeared. So this is our coordinate axis, x-axis, y-axis, negative x, and this one is minus y. Suppose I want to draw a rectangle. I want to draw a rectangle like this, and the dimensions are this is 5 and this is 3. The units are mm. Now, if you keep like this, one more information is missing. What is the information means? With respect to origin, what is the location? I can create the rectangle with dimensions 5 and 3 millimeters, but I can't place exactly where you want. So there is a missing of one dimension. At least you have this dimension, that is origin to one corner, or else from axis to the edge or another axis to the edge. So among these, if you have any of the dimensions, then you can create this rectangle and you can place the rectangle as per the wish. So these dimensions are missing. So let us take one dimension. So let us take this dimension from y-axis. From y-axis, it is located at 3 mm. 3 mm. So right like this, we have to place. Even you fix this point, fix this dimension, you don't have this reference. So I am, for the convenience of the modeling, I am placing this and taking this value as 2 mm. So now we will start the design as per our constraints. So as I told earlier, whatever design you are going to design in the model in the HFSS, first click this one, click the main point. First go to the draw rectangle. Now the cursor is free to move anywhere in the HFSS workspace. Now click wherever you want and it will show the directions. One is along the x direction, one is parallel to the y direction, y axis. Now you are able to move the other cursor in different directions. If you go in this way, then the rectangle will be formed like this. If you go in this diagonal way, the rectangle will be formed like this. If you go in this, that means top right corner. If you go towards top right corner from the point you have taken initially, then the rectangle will be formed like this. If you go bottom right corner, towards bottom right corner, the rectangle will be formed like this. If you go top left corner, the rectangle will be formed like this. If you go bottom left corner, the rectangle will be formed like this. If you go straight right, the rectangle, no rectangle will be formed, rather it will produce the line. Even you take the rectangle command, it will produce a line. If you go like this towards exactly top, then it will produce a line like this and like this. It will produce a line. Other than this, particular axis directions, if you move any of the possible directions, then it will create a rectangle. So let us fix the rectangle like this. So now the rectangle has created. So the things we have to keep in mind is the things we have to keep in mind is this is the point P1 and this is the P2, and the rectangle will be formed like this. That means the vector direction is you are going in this diagonal way. Suppose this is a point P1 and point P2 here. That means second point where you have double clicked the cursor. Then the rectangle will be formed like this. Then it means you are going in this direction. Suppose the initial point is P1 and the point 2 is P2. Now, if you go in this direction only, then this vector both will emerge and the parallel vectors will form the rectangle as we have seen in the physics and vector notations. So how many combinations are there? One, bottom right, top left, top right, and bottom left is also there. So P1 and P2 like this, it is not a rectangle, so I'm making it similar to the rectangle. So if you go in this direction only towards P2, then the rectangle will be formed. So the point P1 is, let us take, it is a fixed point. Now tell me, as per the dimensions, suppose this point is 2 comma 3. Suppose this point is 2 comma 3, not these dimensions, 2 comma 3. Now, what could be this point? What could be this point and this point, this point and this point? 2 comma 3, and this value is 5 and this value is 3. Then we have to identify these points. Actually, we are working in the two-dimensional planes. Only 2 points we are considering, that is x coordinate and y coordinate. We are not bothering about z coordinate. If you want to place the z coordinate, as we are doing modeling in the xy plane, the z coordinate will be 0. You can keep it at 0. So for the convenience, for your convenience, I am keeping this one as 0 for the z coordinate. Okay. So now I want these points. This point will be, how we can calculate this point? So for all these things, this is the x direction and this is the y direction. All these things, this is the x direction and this is the y direction. So now how we can take these points, calculate these points? Let us check. So this one is 2, 3 and 0. So this one is 2, 3 and 0. And 5 is around y-axis. That means 5 is around y-axis. That means, and this is at the same level. This is at the same level. 5 is at the uh, this y-axis parallel. So 2 comma 3 plus 5. As we are going in this direction, 3 plus 5, that is 8, and this will become 0. So what about this point and this point? This point we don't know. So let us check. 2, it won't be 2. Why? Because here the level here is 2 and here is 3. That means you are going down. Why? Because you are going positive way. So then what will happen? So 2 plus, so this is positive direction. So 2 plus 3, that it will become 5 here. It will become 5 here. Then this will become, this point will become 8 only, but because at this point anywhere the y coordinate is 3, but here at this point the y coordinate will become 8. Why? Because it is shifting 5 values and this is 0. Now what is the point? This point, what is this point? So now here the x coordinate is 5 only, but the y coordinate is 3 as it is and 0. Okay, so in the second case you identify what is the point. So the same point p1 is 2 comma 3, 2 comma 3, and this one will be 5 and this one will be 3. So this point will be p2, we will calculate, this one we will calculate. So how the point p2 will be? So this point is x coordinate is 2 and it is moving towards negative x direction in 3 units. Then 2 minus 3, how much? Minus 1 comma. So negative x direction means we have to subtract 2 minus 3, that is minus 1. And what is the y value? So here the y value is 3. So I am keeping its z coordinate is 0. So here the y value is 3. So 3 in the negative direction, negative y direction 5. So 3 minus 5, how much? Minus 2. And the z coordinate is 0. And what about this point? So here the x value is 2, but as you're going in this direction, the point is not here, here, it is here. Then the x value will be 2 minus 3, that is minus 1, minus 1. And y value will be 3 as it is, z coordinate will be 0. Next, what about this point? If this point is, the x-axis is at the same level, so 2 and 3 minus 5, that means minus 2 comma 0. So this is the point coordinates here. And now we will take this particular thing. So 2 comma 3 comma 0. So 2 comma 3 comma 0. This is the point. Now the values are, x values are 5 and 3 here. Calculate this p2 point. So you are going in this direction. That means the resultant direction are positive y and negative x. So whenever you want to calculate the x coordinate, you have to do the subtract operation. Whenever you want the y coordinate, you have to do the addition operation. So that is the simple logic we have to follow. So p2. So how much? X coordinate of p1 is 2, and it is moving 3 units upwards. That means 3 units in the negative x direction. So 2 minus 3, how much? 2 minus 3 is minus 1, and here also minus 1. So the points which are along the same parallel line, the what is the axis perpendicular to it, that coordinates will be equal. So here P2 point and this point are on the same line, which is parallel to y-axis and perpendicular to x-axis. So the perpendicular axis coordinate points are equal. So that is the logic we have to keep in mind. So now 3. Here the y coordinate is 3, and here the same y coordinate will be there. And here, as it is moving 5 units in the positive direction, 3 plus 5 is equals to 8, and this value is 0 and 0. So like this we can calculate these points. Next, what about this point? So the same points which is parallel to y-axis and which is perpendicular to x-axis, then x coordinate will become equal, and this y coordinate will be 3 and plus 5. How much? 8 and 0 here. Let us take the fourth possibility, fourth case. So this is 2 comma 3 comma 0 again. Now we will check this point. This point I am writing here. So 2, and this one is 5, this one is 3. So same these 2 points on the same line which is perpendicular to x-axis, that means x coordinate will be equal and y coordinate there should be change. Here 3 and the vector is going in this direction means in this direction means positive x, negative y. So during y calculations, we have to do the subtract operation. So 3 minus 5, how much? Minus 2. And z coordinate is initially it is 0. And what about the point 2? P2. P2 value is here the position of the x, here 2 and here it changes. So 2 plus 3. So x is positive. So 2 plus 3 we have to do. That is 5. 2 plus 3 is 5 and y value will be equal. So here what is the y value? Minus 2. The same minus 2 will be there and 0. So what about this point? Here also y value is equal. There is no change. So we can keep 3 as it is. We have to calculate this one. So 2 plus 3 is 5. So like this, we have to uh, uh, find out the values and we can change the values if the structure is arbitrarily drawn. So according to this point, so let us take which point you are keeping as P1 and which point you are keeping as P2. So you can draw the structure, you can draw the same structure like this. So I am, for ease of convenience, I am replicating the structure in 4 types. I'm replicating the structure in 4 types. One is like this. Sorry. One is like this. And the second one, again, I'm taking the same graph, same coordinate system here, the same coordinate system here, the same coordinate system here. So as we have the 4 possibilities, first I am numbering them, the list of possibilities. So this is the first one, this is the second one, this will be the third one, this will be the fourth one. Our aim is to design this rectangle with these dimensions 5 mm, 3 mm length and width, and the rectangle should be 2 mm from the x-axis and 3 mm from the y-axis. This is the position. So how we can draw? How you can draw? You can draw the things like this. You can select this point as P1 and this point as P2. Then the direction will be like this. Then the direction will be like this. Next direction means you have to navigate in the direction to form the rectangle. Suppose if you start from this point P1, from this point, to make the rectangle as it is here in this location, then you have to go like this. If you have taken this point P1, then you have to move in this direction to make the rectangle as it is with this lengths and distances. If you want to take this point, then you have to move in this direction to make the rectangle to situated in the same place as we have seen. When only then the same rectangle, the rectangle will be located in the same space and the same location. Otherwise, the shifting or moving operation can be observed. So according to that, we have to plan. So first, in this case, what will be the coordinates we have to see? In this case, what are the coordinates we have to see? Now we will see the all 4 cases in which we will see the point coordinates P1, P2. So P1 is the point where we are starting the design by fixing a point, and P2 is the point where we are navigating to form a rectangle. So in the directions specified, in the directions, if you navigate, then the rectangle will be completely formed. So now we will take the case 1. Let us take this case 1. So what is the values of P? What are the values of P1? So P1 will be the initial point, the position 1. So we have to write the points. This is origin 0, 0, 0. So P1 will be, first point is x coordinate. From x-axis, what is the value? So from origin, this is the level. So already the total dimension is 3 along the x direction, and here the dimension is 3. So 3 plus 3 will be 6, but that 6 is in the negative direction. So minus 6. Catch my point? Next, y coordinate. What about y coordinate? So we are talking about this point. Then from x-axis, what is the distance? That is y coordinate. From x-axis, what is the distance? That is y coordinate. So what is the distance here? 2 mm. So 2. The 2 is in along the positive y direction. So plus, and z coordinate is 0. So what about point P2? What about point P2? P2 will be the x coordinate. We have to calculate the distance from the y axis. So this is the y-axis. This is the distance. How much? 3 mm. But this 3 mm in what direction? Negative y direction. So minus 3. And what about this y coordinate? Y coordinate is obtained by calculating the distance from x-axis. So from x-axis, what is the distance? So this distance plus this distance. So total, this one is 5 and this one is 2. 5 plus 2 is 7 and this one 0. And as we are moving towards positive y direction, so positive sign will be there, which we cannot, we no need to mention it. So these are P1 and P2 points. So take these in a box. Next, let us go to case 2. Let us go to case 2. Now we will write the P1, P2 points. So P1 is here and P2 is here. So P1, the point is here. That means x coordinate is the distance from y-axis, nothing but 3. But as we are moving from y-axis in a negative direction, so the x coordinate is minus 3. And the y coordinate will be calculated from the distance from x-axis, that is 2 mm, which is along the positive y direction. So plus 2 comma 0. And this P2 point, this point, so definitely the x and y positions will be changed. So x coordinate will be considered from the distance from y-axis, that is from here to here, that is 3 and 3, totally 6. But we are moving in the negative x direction, that's why minus 6 comma this one, how much? Y coordinate. Y coordinate is the distance which are calculating from x-axis. So this is 2, this is 5, and we are moving towards positive y. So plus sign will be there. 2 plus 5 is 7, and this one is 0. So P1 and P2. These are the points. Now we will move to the third case, where the P1 is top right point and P2 is bottom left point. So P1 point coordinates will be, P1 point coordinates will be x coordinate, which is the distance from y-axis. How much? 3 plus 3, which is 6. But we are moving in negative x direction, that means minus 6, comma y coordinate. How much? Y coordinate. This is the distance from x-axis, that is here the distance is 2 and here 5 is added. So 2 plus 5 is 7, which is positive y direction. So plus 7. And here this one is 0. P2, P2 is this point. So x coordinate is the distance from y-axis, nothing but 3 in the negative x direction, so -3, and y coordinate is the distance from x-axis, which is from this is the distance 2 mm, and it is in the positive y direction, so 2, and this one is 0. So like this we can calculate the position coordinates. Now we will see the fourth point, fourth possibility, in which the P1 is here, this is the P1, and this is the point P2. This is point P2. Now P1 is how much? Can take the x coordinate is the distance from y-axis, nothing but -3, and y coordinate is this point. So y coordinate is from here x-axis to how much distance? 2 plus 5, that is 7, which is in the positive y direction, so no problem. 0. P2, so what is the position to P2? P2 is this point. So x coordinate is from y, how much distance is there? So that is 3 plus 3, that is 6, but in negative direction, so -6. And this one y coordinate, how much? From x-axis it is having 2 mm distance, so it is in the positive y direction, so +2 and 0. So these are the points. So now case wise, we will draw the rectangle in the HFSS, and we will try to draw the same rectangle in 4 manner. So first, arbitrary means with your known dimension, with your desired dimension, you can draw a rectangle. But if you want to change the dimension, how we can change? So we have our constraints. As per our constraints, we have to draw the rectangle. So click on the rectangle. Next, create rectangle. Click on the create rectangle. Double click on that. Now properties window will be appeared. Position. This position is nothing but the initial point. So suppose some person has designed this rectangle, but we don't know at which point he has started. So how we can identify it? So here the position coordinates are negative, negative, minus, minus in the xy, and x size, y sizes are positive. So now in the all four cases, in which case the xy sizes will be positive, that is obtained in the first case. Here you can identify the x size, y size not positive here. So x is negative here. Here I will write. So here x is x positive, y positive. Here x negative, y positive. Here x positive, y negative. In this case, and in this case, x negative, y negative. Okay, so x positive, y positive is the case only in the first case. So in the first case, what is the criteria? P1 is top left, P2 will be bottom right side of the rectangle. Okay, like that you can identify which is the case. So now we will check, we'll keep the points as per the first thing. -2 6 -6 2 0, -6 2 comma 0. Just enter those values, -6 comma 2 comma 0. So all the units are mentioned as mm, so no need to mention. If you don't mention the units but variables, then it will take into meters. By default, units are meters as per the SI units. So we have to be careful with that. So -6 comma 2 comma 0, this is the first position, P1 point. Now the x size, y size will be what? X size will be positive, y size will also be positive. then how we can mention those values? So what is x size? What is x size here? What is x size here? The x size is which is parallel to the x-axis, nothing but 3 mm, and this one is 5 mm. In this case, how we can identify in the second case? Here the 3 mm and 5 mm. Here x is negative, y is positive. That means the sizes can be represented as x direction 3 mm is there, and y direction 5 mm is there. But we have to keep the signs. So it is minus 3 mm, this is 5 mm. And here x positive and y negative, that means the values will become x positive means x dimension is 3 mm. First write the dimensions values. Y value will be y size will be 5 mm. Why? Because the length is along y axis, the width is along x axis. Don't confuse. So 3 mm and 5 mm. So x positive, y negative. So minus 5 mm. In this case, what could be the values? So x size is again 3 mm. This one is 5 mm. So both are negatives, minus 3, minus 5. So like this, we have to place the values. So what he is asking, as per that, we have to convert our things. So minus 620, x is 3 mm, y is 5 mm. I'm replacing. Now click on apply. Okay. Now control D. If I click on the control D, then you can see this structure, which is 3 mm from this y-axis, 2 mm from this x-axis, and this total length is 5. This one is 3. Whether it is correct or not, we have to check. So go to measure option, position. From any point from the y-axis, just click on that and click on the edge. Any point on the edge, you just check the x distance. So past tracking. So x distance is 3 mm. X distance is 3 mm. Is it correct or not? Yes, is it correct? X distance is 3 mm. And next one. So from x-axis. So locate a point on the x-axis. Click the cursor on the x-axis, and just place the cursor on any point on the edge, any point on this edge of the rectangle. Now check the y distance value. So y distance is 2 mm. So what we have taken in our design, our constraints 2 mm. So 2 mm, 2 mm is matched. So perfect. Next we will check the length and width. So click any of the point here, this point or this point, just place the cursor here. Now what is the y distance? 5 mm. So the length is 5 mm that we have taken already. Next, from just click this point and you can check this edge length or this edge length. Click one, 3 mm. So x distance is 3 mm. Yes, it is perfect. Otherwise, you can check these lengths in another way. Right click, escape, and measure. Right click on the workspace. Go to measure option. Click on edge instead of position. So now click on this edge. It will show rectangle 1 is a structure, edge 3420. So length of the edge 3420 is 3 mm. And here the length of the edge 3422 is 3 mm. And this 5 mm. And this edge is 5 mm. So like that we can measure the edges. And here I would like to tell you one point. Let me let you know one point. When you are checking the measure option using the position, the cursor which is in the workspace will be in a rhombus shape. But you see that black dot, the black cursor, that is in a rhombus shape. But whenever it is positioned, just you place the cursor on the corners of the structure, then it will be shown as a big square, big black square, big black square. Here one corner, this is another corner, this is one more corner, this is one more corner. So at four corners, it will be appeared like what? Big black square. Next, we will see the midpoint. So this is the edge midpoint will be here. So edge midpoint is shown as triangle. So edge midpoint is shown as triangle. Okay. Next, half of the mid length. Half of the mid length. So you can just move the cursor along the edge. At one point you find this different cursor. So that cursor is quarter circle. Quarter circle. So quarter length will be represented with quarter circle. Midpoint will be represented with triangle. Corner points will be represented with big black square. Here another midpoint, or midpoint of the edge, and quarter point of the this one edge. So one fourth length. Okay. So here also quarter point lies here. Here also quarter point of this half of the length is lies here. Then another one more point will be there, that is at the face center. So face center will be represented as a circular dot. Face center will be represented as circular dot. And horizon, at the horizon also circular dot will be there, but it won't be appeared properly due to the other coordinates overlapped over there. So this is the modeling of the rectangle as per the first one. So now I will draw another rectangle in different manners. So let us draw here, but I want this rectangle at this particular location. How I can convert this? So I am checking the second case, taking the P1 point minus 320, P1 point as rectangle 2 minus 3. I am directly writing these position coordinates in the properties window. Minus 3 comma 2 comma 0, and x size y size. In this case, what is the x size and y size? So x is negative, y is positive, 3 mm and 5 mm as we have already calculated. So this is 3 mm, this is 5 mm. Let us check. Let us check. Now what happened? What happened? Problem. So click on the rectangle to create rectangle, double click it. Now actually 3 and 5, but the x value will be minus 3. So that's why the structure mirror duplicated like this. So now to click on the rectangle one, this is the initial one. Let us take another color for this rectangle, this color. Okay, it is not visible. But right wherever the rectangle one is there, at that location only rectangle 2 is also getting selected. That means the rectangle 2 positioned correctly as per the rectangle 1 position. So if you do like this, the structure will be aligned here. If you do like this in the second manner, the structure will be in the same position. So now we will take another rectangle. I will draw in a far more distance, or I will draw like this. So in the third method, what we have to do, point P1 here, and I am going towards bottom left corner. Then the values will be P1 value is minus 670, 3 minus 5. Okay, minus 670. Now click on this, double click on this. This point is minus 6, comma 7, comma 0, and this 3 and 5 we just keep it. Okay, click on apply. Now what happened? Beside this initial rectangle, the newly created rectangle just situated, but it has to be flipped horizontally. If that happens, the position is correct. So what we have to do for flipping? Can we change the sign of the x size, or can we change the sign of the y size? So here the key point is we have to flip the rectangle. The dimensions are same, but we have to flip the rectangle, then it will be correct. Then the flipping will be with respect to positive y and negative y, so that the -5, if you keep here in the y size, then the rectangle will be disappeared, and if you click on this, the same rectangle will be here only in the in its actual desired position. Now I am drawing another rectangle to validate the fourth method, fourth possibility. P1 is at the bottom right corner and you are navigating towards top left corner. So in such case, the coordinates are -370, -3 comma 5. So -370 is the coordinates. Just click on the double click on this create rectangle command. Change the position. What is the point? -370. So -3 comma 7 comma 0, and this point x size is 3, y size is 5. We are no. But what happened? Just check it. What happened? Just check it. So now this is the point. So this is the initial rectangle. This is a newly created rectangle. So it is not aligned here. So if this point meets here, if this rectangle flipped along this diagonal path, then this rectangle will be exactly overlapped with this one. So then how we can create? So I will deliberately, actually, let us take these values are not considered, not calculated. Then people who didn't calculate these values, they will try on changing the signs. So what is happening? Just check it. So if you first try, I'm placing -3 here, just apply. So it came here. Okay. In the second try, I will remove the minus here and put the minus here in the y size and apply. Then the rectangle, newly created rectangle appeared here. So this is also wrong. So another possibility, this one also, if you keep minus, then it is located in the same place. So this one is correct. Otherwise, some people will do changing the sign not here, and they will simply change the sign here. Then what happens? Just 370. So the rectangle will be formed here. Okay. Next combination 3 -70. The rectangle was shifted here. Okay. The same configuration 3 -70. Now 370. Then the rectangle is here. -370 here. -3 -70 here. So like that, the positioning is getting changed. So what is the actual coordinates? We have kept -370. Right? Earlier it was there. Now if you keep -3 and -5 here, these are the actual locations. So rectangle 1 is here, rectangle 2 is also there, rectangle 3 is also there, rectangle 4 is also there. But we have taken 4 different methods, 4 different possibilities. We have tried with 4 different possibilities. Next thing, we will see the Boolean operations, or not Boolean operations, the translation operations, which are called move, rotate, and mirrors. So let us take rectangle 1, move operation. So you can move that rectangle with respect to a reference position, which may be corner, which may be center of the edge, one of the edge, center of the another edge, center of the another edge, center of the another edge, or quarter points, any of the point you can take it as reference, or face center you can take. So move. So let us take from center to like this, like this, like this. I can move this rectangle. So if I move this rectangle here in this location, there are 4 rectangles are there. So rectangle 1 is here, 2, 3, 4 are same here. So now I am moving the rectangle 2. So I am taking face center and moving. So while moving, you just check position 1 and position 2. So if you if you find the other coordinates are also getting changed, which are earlier 0. That means the movement is not in the same plane. The movement is also there in the other planes. And one more thing we have to observe is here three things are there: dx, dy, dz. Dx is nothing but x distance. So here what is the value? 7 mm. Here what is the value? 7. And dy is how much? 6 mm. Dy is how much? Here now 6.5 mm. Now how much? Minus 6.5 here. That is the distance given in the measured data. Distance cannot be negative. But the dx, that means dy means change, variation. So variation indicates the direction also. So minus 6.5. And there is no variation in the z plane. So the z axis. So dz will be 0. So this is the point. So like that, we have to check everything. Next, rectangle 4, I'm moving. Um, any other point like this. Okay. So now these are the, so earlier rectangle 2 was given color, given this color. That's why it is showing in red color. Another point. So rectangle 1 I'm taking. Now I am selecting the along line option. So along line option, what is happening? So I am moving this line, moving along this line. Click on this. Now it will ask duplicate along line. How much number? Total number is 2. If you place 2, that is the minimum number, then it will duplicate. Or it will play 5. If I give 5, okay, then this. So this option is very much useful to create array antennas where more than one element are existing. So this is the moving along line, that is duplicate along line. And duplicate around the axis is there. So not uh, duplicate around the axis. If I consider this one, it will check. So before doing this operation, you should not fix the cursor at point. Why? Because if you fix the cursor, then the orientation will change. So you can choose the zoom tool. Now here the axis will be there. Axis, if default z axis. So you can change it to x and y. So now 90 degrees. So already the structure is like this. Length is around y axis. Now the length will become parallel to x axis. So this is for total number of 2 for 90 degrees. If I change the 45 degrees, then what will happen? So this angular orientation will be obtained. So if I do these kind of things, so this many number of structures I can develop, right? So like this, the structures I can develop using the rotate option. So all these options are these tasks where it resides. So I am performing the task to rectangle 1. So select the rectangle 1, then it has created a rectangle using this command. Next we have moved. Next we duplicate around line. Next we duplicate around the axis. After duplicate around axis, we obtained rectangle 1 underscore 1, rectangle 1 underscore 2, this one. So you just click on this move option. Now check the properties, check the move vector. So 0, 8.50. If you want to move in another line or another direction of your required length, then let us take, I want to move to 15 mm along y-axis. So then the structure will be like this. So after move option, we perform the duplicate around the axis, duplicate around line. So movement will reflect these things also, that we have to keep in mind. So hierarchy is comes into picture. Now if you change the value to 7, now what will happen? So like this. So change the value to 20, then the structure will be like this. Double comma was obtained, so I will apply. So 20. So earlier rectangle was here. Now after moving the rectangle came to here, then we duplicated and rotated. or duplicate around the axis. So if you want to reduce this one, so you can't reduce. So before that, you have to fix how many number of duplications should be done. And you can change the angle, but we cannot change the total number. So angle, if I change 30 degrees, then the structure will be like this. 60 degrees, 60 degrees, then the structure will be like this with 9 number of components. Where are the other components? Only 1, 2, 3, 4, 5, 6 are there. Other components will be overlapped over here. Okay, 10 degrees, then like this. 20 degrees, like this. So like this, you can do the experimentations of your required dimensions and required structures. So if you delete this option, what will happen? You delete this duplicate along line. Suppose you delete this duplicate along line. So no duplication will be occurred. I'm doing redo operation and I'm getting that same things. Okay. Now I am duplicating the duplicate around the axis. No duplication. So rectangle 1_1 and other things were not there. So earlier, what happened? Earlier, rectangle 1_1. These are the duplicated options. Duplicated options. These are also duplicated, but duplicate around. Okay, duplicated around axis. So these things I have to delete at once. Then there are two options. First of all, select what are the structures you want to delete. Another method is directly delete that command. It will simply delete that task and duplicate around line. I don't want this, so simply delete it. Okay, here I don't want the move operation, simply delete it. It will be reflected at the same position. So this is the thing. Next, coming to the planes here, global XY. This is the global XY representation. Global YZ, the plane we can't see here. If we change that, if you rotate the coordinate system, the plane will be visible. Global YZ, this is the YZ plane. If not, you have created another coordinate system, then it will go under relative coordinate system. Earlier we have kept some points, point P1, where is it? So this is the point P1 and point P2, it is there. Okay, earlier with point 1, point 2 dimensions, we have kept the points. That points are represented here. So I am deleting those points. And lists means all objects. What are the objects available? Those objects will be appeared. And I didn't mention this project manager window. So project manager window, the file project name will be appeared here. The star will be indicated here. That means you are working in this project. So you can create another project. You can create another project. You can create another more projects. So in this project manager, how many projects are there? Project 2, project 3, project 4. But this workspace is reflecting which project you can identify based on this star. This star. So the star will indicate the working project. Then you can easily navigate. So in that project, if you open these options, what are all the options available? We just check it. So initially we have inserted a HFSS design. So it is the first design, that means HFSS design 1. This design 1 is for this project. If you are in this project, I'm just double clicking. Next, click this HFSS. Now HFSS design 1 for this project 3. Then the star mark will be appeared. And here no modeling was there, no star mark, but here modeling already done, so star mark is there. And under this HFSS design 1, 3D components are there, model is there. So just we check 3D components, model, boundary conditions. Suppose this is the rectangle, and now we want to apply boundary condition to rectangle 3. So how to assign the boundary conditions? Just click on the rectangle, select the rectangle, right click, go to the assign boundary option, Just check what are the boundary options are there. Anisotropic impedance, aperture, finite conductivity, half space boundary, impedance boundary, layered impedance boundary, linked impedance boundary, lumped RLC boundary, master, perfect electric, perfect magnetic, that is perfect H, radiation boundary, slave boundary, master boundary, slave boundary are two combination things. Symmetry boundary, PML, perfectly matched layer setup wizard. Okay, so now I want to make this rectangle as a conducting surface. So if any structure, if any surface should be would be worked as a conducting surface like a copper, aluminum, or any other metal, then we have to apply the perfect E boundary, perfect T boundary. So here the name automatically it has given perfect E1. Suppose the structure is with respect to a sheet or patch, then we can rename it as perfect E patch. Suppose another rectangle which acts as a ground plane for a patch antenna, then perfectly ground. Like that, we can rename the structures. So after assigning the boundary, what happened? Earlier in the unassigned section, there was four rectangles, but now that rectangle three was categorized into perfect E boundary, which is under sheets. So this thing we have to notice. After that, what is the observation we can do? We can get. So under boundaries, perfect E patch was obtained. So just click on that. So perfect E patch. This is the perfect E. Just click on this. It will show the structure which is assigned as perfect E patch boundary. Next, excitations for giving the input signal for simulation, and hybrid regions, mesh operations, analysis, optometrics. Analysis means for doing the simulation. Optometrics is for optimization through parametric analysis and based on algorithms. Results after doing performing the simulation, what are the results you are getting? And the port field displays. Port field is related to the excitations. So you are assigning the excitations with different excitation methodologies. So at the ports where the signal is entering or signal is leaving from the device, what are the fields and what are the modes we can identify. And field overlays, radiation are these options we will discuss by doing the simulation with an example. So this is about modeling and a few things. And I'm going to explain one Boolean operation. So suppose this structure is there. Suppose a circle is there. Click on the circle. I'm going to draw a circle. Click on the circle and click on a point in the workspace. Now I am drawing a circle. Suppose I want to subtract this rectangle from the circle. Then what I have to do is first I have to select the circle 1 and click the rectangle next. That means for which rectangle? This one, rectangle 2. Okay, rectangle 2. Now I am doing the subtract operation. Here the blank part is there and tool parts are there. So blank part, that means after subtraction, in which structure the blank will be obtained? Nothing but circle. Okay, so doing this. After doing this operation, if you want to invert this, just select, just move here and just select this rectangle and move here, and the operation will be changed. Okay, we will change as it is like before. Let us see how the structure will be. So what happened? In the circle, another node is created, that is subtract node, subtract operation, Boolean operation. In that rectangle 2 came. So what is the resultant structure? This circle one only. But the circle one is nothing but this one. So what is this? What is this? Already is there. So I want to hide this one. So hiding is like this. So this is also I want to hide. So the resultant structure is like this. Suppose I don't want this operation. Now do delete the subtract. Now you can identify this. So first let us do the subtract operation from rectangle to circle. So do the subtract. Now this type of truncation you can obtain. Suppose we want to add these structures. So you can add a circle to rectangle, then circle 1 to rectangle 1, then rectangle 1 will go into circle. So based on the hierarchy. Sorry, this is not the rectangle 1. I think rectangle 1 also I am adding. So this circle and rectangle. First I am selecting the circle, second one I am selecting the rectangle, then unite. What happens? Under circle 1, rectangle 2 will go inside. Okay, the resultant structure is this one. Suppose I am deleting this unite operation. Now I am selecting rectangle 2, then circle 1. Now doing unite operation. So then also same structure, but the thing is under rectangle 2 node, the circle 1 went inside. So that is the thing. So like that, the rectangle 2 properties obtained here. Earlier, this was not the color of the circle. Now, rectangle 2 color was red. So the same color was attributed. Got it? Next, intersect. So I'm reverting this operation. Now, checking this intersect. So clicking this one and this one, do the intersect. So common part will be get highlighted. So this is the Boolean operation. And you do the intersect from rectangle to circle. So then under rectangle, intersect node under which circle 1 is there. So like that. Next, split operation. Split operation cannot be performed. Yeah, yes, it can be performed, but we can perform with respect to y-axis. Suppose circle 1, I want to do the split. So if you select this structure, only structure, then no unite, no subtract, no intersect will be enabled. Only split operation is enabled, and other these options are enabled. So click on the split. Now it will show the particular thing. So split method, split using XY plane. So are you going to split using XY plane? So if you want to split using XY plane for the structure which is already there in the XY plane, then it won't be done. It can't be done. So you can split with respect to XZ plane. If you want to split in the XZ plane, then the structure is not intersecting the XZ plane. So no split will be occurred. So you have to change the YZ plane. So and keep result, there are three options: positive side, negative side, both sides. Positive, negative, both. So I want to keep both. Okay. If you want only positive side, that means positive part, as we have already discussed about the coordinate quadrants. Okay, negative side and this side, both sides. Split objects, split all objects or split objects crossing split plane. These options you can select. So delete invalid objects created during operation. Where the objects are there which are treated as invalid, those can be deleted if you tick this option. So click on this. Then the circle which was earlier it was complete circle. Now it is divided into circle 1. In that split, you may get the doubt. Where is the circle 1? It is not completely showing. It is showing like a semicircle, not a semicircle, but it is somewhat truncated. So how the other people can identify means they will just click on the circle 1, then they maximize this one, and they will check the one by one step by step operations performed. So automatically the split edit is there, so that they can easily understand, yes, this circle one is splitted. So where is the other part, they will automatically check. So already we have given that point. So circle 1 split 1, so this is the remaining part. So in this, the command is split from, here split edit, here split from. So split from what? Circle 1. So if you want to change these parameters, suppose this parameter circle position 280 and the radius is 6. Let us take the radius is 12. Then also split exist. Now this one and this one. Dimensions are changed. We can do. Now not only we can do here, we can also do the changes here. Right? Because this is also circle 1, this is also original circle. So both are original circles. Why? Because split from operation is there, right? So split edit, you can do the edit operation. So suppose you keep xy no split. As there is no split, there will not be any object created, resultant object created. It will be treated as unclassified, unclassified circle one like this. If you revert this one, then no unclassified classification will be obtained and the earlier circle will return back. Okay, this is few things about the linear structures, that is line, spline, three-dimensional, three-point arc, center point arc, and this 2D surfaces. We will see other modeling processes in the next video. Thank you all. Please please do like, subscribe our channel.